All right, so let's work this one out. I want to preface this by saying that there are some ratios in here that we can potentially use. For example, we have a particular ratio that we can use, such as 3, 4, 5, and so on and so forth. But we are not going to use that. We instead are going to just go the long way, just to get more practice with our trigonometry, and that is going to be the best way to approach this problem. Also, looking at this problem, we see that we can do moments, and I'm not gonna do that just yet. I first want to do the free body diagrams at certain particular points, and from there we can just start to see what steps we can skip. One of the first things that we have to do is that we have to check, or we have to uh, check for reactions. In this case, we have the pen. We already know that we are going to have two. One of them is going to be AX and AY. Okay, so we're going to do AX and AY. For a roller, we know we have only one, and that is going to be AY. We're also given that P1 is equal to 40 kilonewtons and P2 is equal to 20 kilonewtons. So the way that I'm going to approach this is that I'm going to start at point A. I will then move on to point B. From there, I'm going to go to point E. And then I'm going to go to point D. Again, this problem is going to be a bit longer than usual, but we'll try to get through this as fast as possible. So like I said, point A, one of the very first things that I like to do is I like to do a free body diagram, as I've said in class. So I'm going to do point A. I have a reaction going up. I also have AX. I have this force AB. And then I also have this force right here. And actually I should have done force AB going the opposite, but that's fine. Remember one thing, the direction, you're essentially guessing what the direction is. If you get a negative value, that just meant that it was supposed to be the opposite way. Another thing that I'm gonna do for this problem is that I am not going to involve any of the compression or tension that is going on in here. I'm gonna try to keep it as simple as possible. Our main focus is going to be the free body diagrams. If we have any forces at an angle, then breaking it into its vector components, and then just doing the sum of all forces in the x, sum of the forces in the y, and just getting a value for the forces. That's the main thing right here. And then later on, as we move through the class, we will figure out where we have tension and where we have compression. Okay, so I have another force, which is force AG. Okay, now from here, after the free body diagram, I have to check if I see any angle that is I need to check for any force that is at an angle, and I actually do have this one, which is force AB. I'll break it into its vector components, move in this direction, and then I need to go up to get to my destination, and this is going to be my x, and this is going to be my y. The angle that I'm interested in looking for is going to be this one. I know that the length for the x is 1.5 and the height for it's 2 meters. So 1.5 and 2 meters. And I can actually just draw a quick triangle in this case, in which this is the angle. I know it's 1.5, this is 2. Trig tells us that I can use tangent of theta equals to opposite over hypotenuse, with opposite over adjacent, which is 2 over 1.5. Theta therefore is going to be tangent inverse of 2 over 1.5. And when you put this in the calculator, you end up with 53 degrees. And so that is going to be the angle measurement that we're going to be using. Okay, so my x component in this case, and I think I'm gonna actually put it in red, is going to be, let me redraw it over here. I'm gonna have force AB, this is my x, that's my y, and I found this angle to be 53. So then to find my x and y component, I'm just gonna do sine of 53 is equal to opposite over hypotenuse. Remember SOHCAHTOA? SOHCAHTOA, sine opposite over hypotenuse. I multiply both sides by force AB. This cancels out, so I end up with force AB sine of 53, and that is my y component. I will do the same thing for the y, for the x. So I'm gonna have cosine of 53 equals to x over hypotenuse, which is force AB. Multiply both sides by the force AB. Cancels out, and I end up with force AB cosine of 53, and that is the x. Now, this is the only time I am going to go over this. Throughout the whole video, I'm just gonna assume that you all know how to get the rest. If in any case we have to find more vector components. So I found my y component, and I found my x component. At this point, what I can do is that I can do the sum of all forces in the x and the sum of all forces in the y. So sum of all forces in the x must equal 0. So what do I have going on the x? I have ax, I have force ag, and I have this x component. Ax is positive. Force ag is negative. And force AB, cosine 53, is positive. How do I know how to use this? Well, again, there's also why we broke this force into its vector components. We broke it so that we can figure out, hey, this is the x component and that is the y component. Okay? So I can put it in here. So that's going to be force AB cosine of 53 is equal to 0. Now at this point, I can't find anything. I don't know what AX is equal to. I do not know what force AG is equal to. I do not know what force AB is equal to. So now I try the sum of all forces in the Y, and let's see what I get. So along the Y, I have AY positive, and I have only this component right here, this component, which translates to force AB, and that is positive. So plus force AB sine of 53 equals 0. Again, there's no way I can find anything just yet. So I'm gonna leave it at that. Because I don't know what, again, I don't know what force AB is equal to. I do not know what AY is equal to. So I'm gonna move on to do point B. Actually, point B, I could do point B, or I could just move on to do uh, point E. Why don't we do point E? Let's see if we have anything from point E. Okay. So at point E, see if I can paste it. I'm trying to paste this here. There we go. At point E, which is here, I have 1, 2, 3 reactions or forces, right? So point E, I'm gonna have EY, I'm gonna put this force going downwards, and that's going to be force in DE. And then I'm gonna have force FE. So I'm gonna have this force coming in. There is going to be force FE. And I'm gonna do the same thing as I did in the previous step. I have a force at an angle, which is force DE. And this is my Y component. That's my X component. The angle that I want to use is this one. And again, using trigonometry, I eventually find out that this is 53. You guys can go ahead and prove that. So again, like I said, I am going to skip this step because now I know that sine of 53 is equal to opposite over hypotenuse. But I know that eventually I'm gonna end up with this here, and I can have now force DE cosine of 53 is equal to dx. So I found my x and my y component. Now I can do the sum of both forces in the x, and they have to equal to 0. Now, along the x, I'm going to have this force and this x component. So I'm going to have force Fe and plus force dE cosine of 53 equals 0. I will go ahead and do the same thing along the y. All right. And so then I am going to have EY, and I have this y component, and since it's coming down from the tail of the arrow, it's going downward, that's gonna make it negative. Force dE sine of 53 equals 0. Again, I'm stuck because I don't know any value. I do not know what force Fe is. I don't know what force DE is. EY and DE. So, now I start to think, okay, am I gonna get to a point where I'm just gonna be left with a whole bunch of free body diagrams, a whole bunch of sum of forces, and nowhere to go? If that happens, that's when you can start doing moments. How do moments work? Well, moments work like this. So I'm just not separate all of this. You know what? Let me just move this guy. I'm gonna move it over here. And I am going to move all of this to the side. Okay, that way I have space. Okay, so moments. When we do moments, we look at the entire frame as a whole. We look at the external forces that are happening. We don't look at this force here or that force or this force. We are more interested in the external forces, which in this case is P1, which we know that that is, I believe it is 40 kilonewtons. So I'm just going to put 40,000. And this is 20,000 newtons. We also know that this one is EY. This here is going to be AY. And this here is going to be AX. Roller has one reaction, pin has two reactions. Those are the external forces in this case. So for a moment, we're gonna assume that if it rotates clockwise, this here is going to be positive, and one of those points is going to be fixed. So in this case, I actually want point A to be fixed, and everything else should be able to move freely. Okay. Doing so, we can start figuring out some of these values. And I'm gonna do the sum of all moments about point we say we want to do a point A so that we can have so that we know what EY is equal to. And so I'm gonna do moments about point A, and then mass equals 0. Okay. So then I have this is fixed. Again, this point is going to be fixed. That's not going to move, and everything else is gonna be able to rotate. And it's gonna be able to rotate in that direction. Actually, you know what? Let me do that again. We have this force here, P1, and that's pushing it down, which is gonna make this entire thing rotate clockwise, which is positive, right? P2, if you push down on it and keeping in mind that a point A is fixed, this force is gonna push it downwards, but since it's fixed, it's gonna make it rotate in that direction. EY is gonna make it rotate upwards. Now, let me clarify something. It's not going to move upwards, okay? In any case, P1, P2, or EY, it will not move like that. Reason for that is because, again, it's fixed at point A. Right here is fixed. That's the reason why it would just rotate. So in this case, EY is pushing it up, and that is going to make it rotate in that direction. So it's going to make it negative. So it's going to make it positive, and that is going to make it negative. Okay? All right. Now, having said that, now we can start putting things together. Remembering that a moment is equal to the force perpendicular to the distance. So we have a force P1, right? We have this force, and perpendicular to that is the distance of 1.5. For P2, we have this force, and perpendicular to that, we have the force with the distance of 4.5. And then EY, we have this force going up, and the distance, the total distance is just the summation of all of those, which is 6. Right? So it's EY, this is P2, and P1. Again, notice how we have all of those forces, and how we have all of those distances. and they create that 90-degree angle. Okay, all right. So we will have P1 times, well, in this case, we know what P1 is, so I'm just gonna put that as 40,000 times 1.5 plus 20,000 times 4.5 minus 6 times EY. Okay, which is equal to 0. I know I put the distance first. It's just, it's algebra at the end of the day. I'm going to move this to the other side of the equation, and I end up with 6EY is equal to, once you put all of this into the calculator, 40K times 1.5, and then 20K times 4.5, you end up with 60,000 plus 90,000, and then you divide, you add them up, you divide by 6y. I'm gonna get to the answer, and that turns out to be 25,000 newtons. Okay. I want to do a highlighter actually. And during class, I am going to ask you guys to do this. Highlight your answers in yellow. That way it's easy for me to see where your answers are at. So I have EY. Okay. Now, having found EY, I can go back over here. And so then I'll just substitute EY in here, and I should be able to find DE. So I'm going to move DE to the other side of the equation. And that makes it positive. So I'm just going to do force DE sine of 53 is equal to EY. Hopefully you know how to work with equations, and you understand what I just did. Okay. I will now divide by the sine of 53. You can put the value of EY in here already if you want. I am going to wait until I have this entirety. So force DE is equal to 25,000 divided by the sine of 53. So then force DE that's too much. So force DE equals to, once you put all of this into the calculator, you're gonna get to 31,303.4 newtons. Okay. So either you have highlighted, actually maybe I can do yellow. Is that gonna matter? No, I don't want to do that. Anyways, so that's the answer to that. So either one will work. Highlight it or just change the color so that it jumps out to what I want. Okay. Okay. Now, I found force DE. Next thing that I can do, now I can put force DE in here, and that should give me the value of force FE. All right. So again, I'm gonna go ahead and move this to the other side of the equation, which is gonna make it a negative. So then I end up with force FE equals to negative force DE cosine of 53, or force Fe equals to negative 31,303.4 times cosine of 53. Once you put it on the calculator, you're gonna get that force Fe is equal to negative 188.34. I should have done it in red. Let me actually do that. Let me just erase it. So force Fe is equal to negative 188.34 newtons. Okay. And so now we found two of them. Actually, we have already found three. All right. Okay. So right now, we found EY, check. We found FE, check. We already found DE, check. Okay. Now we can probably keep moving to point D. If we do point D, we have this here, and we have that force right there. Probably find more values. So let's go ahead and do that. Do I have space in here? Yeah, I think so. All right. So point D. Okay. Point D. I have DF. So I'm gonna put DF going in that direction. Force DF. I will also have force CD. I'm gonna put force CD going that direction. And then I'm gonna put this force, which is force DE. Again, force DE, I already have it. I am not going to do a, another free body diagram, or I should say I'm not going to break force DE into its vector components, just because I already have that in there, which means that I can essentially use those same ones. It's not gonna change because I have the same direction, which it's a huge benefit. Okay, so I'm gonna do the sum of all forces. Perhaps I'll do it on the x. And on the x, I have negative 4CD because it's going to the left, and then I have positive x component, so positive force ZE cosine of 53. So plus force DE cosine of 53, and that is equal to 0. So guess what? We can actually find what the value of force CD is because we already know what that right there is. So I'm going to move this to the other side of the equation, okay? And in doing so, it becomes positive. So I have force DE cosine of 53 is equal to force CD. I'm going to switch this over here and that over there, all right? So then I have force CD equals to force DE turned out to be 3130.3. So it's gonna be 3130.3 times cosine of 53. So then once you put this on the calculator, you're gonna you should get a value of 4CD. Sorry, hold on. Yeah, 4CD should give you, let me make sure I don't confuse you guys because there's 3 of these ones. Then there's going to be 4CD equals to 188. Um, 38.86 newtons. Okay. So we just found another value. Now let's do the sum of all forces along the y. So I'm gonna do it over here. Sum of all forces along the y. I have to do it downwards. Yeah, they have space. Sum of all forces along the y must equal 0. In this case, I have a positive force dF, right? Because it's going up. So that's force dF. And I have the y component of this one, which in this case is going downwards, which is going to make it negative. So that's negative force dE minus force dE sine of 53. And that is equal to 0. Now, I already know what dE is, so I'm just gonna substitute it, and I'm also gonna move it to the other side of the equation. So force dF is equal to, again, 313, 03.4 times the sine of 53. Once you put it on the calculator, you end up with force dF is equal to 25,000 newtons. Okay. And let me highlight this guy here. All right. So far we found a whole bunch of forces already. So we found CD and DF. So we found CD and DF. So we found this. And then we also found this guy right there. Maybe we could do a free body diagram at point B. And that can help us find more forces along the way. So let's go ahead and do that. And let me just separate everything as much as I can, just so that we don't get confused with everything. I know it's a mess. There's just so much stuff going on in here. So okay, so point B, no, point F. So we're gonna do point F. Point F, I have a lot of stuff going on. I have this force Fe, but we already found that. We also have this force in here, and we know what that is equal to. We know this as well. That's force Fd. And we have this force coming this way. I'm just gonna put it like that. Force GF. And we can't forget about this force, which is force CF. There's just so much stuff going on. Okay. So first step was to do the free body diagram. After that, we check to see if we have any forces that are moving at an angle, and we actually do have one, which in this case is force CF. So I'm gonna have that force CF, and I'm gonna move in this direction. That's gonna be my X component, and that is going to be my Y component. Okay. And the angle that I'm looking for is going to be this one. Doing the whole trigonometry, I know that I end up with 53 degrees. And the reason for that, again, is because I know that's 1.5, that is 2. This is the angle that I'll be looking for. Once you do tangent of theta is equal to 2 over 1.5. And you essentially get the same value as last time. You get 53 point some numbers, but I'm just gonna leave it as 53 degrees. Okay, now from here you can get your sine and cosine. So I'm gonna have sine of 53 is equal to the y component and times force CF. By default, I know that force CF is going to be cosine of 53, and that is my x component. Okay. After that, I am going to do the sum of all forces along the x. So I have the sum of forces along the x must equal 0. In this case, I have 1, 2, 3 of them. Okay, so I have force GF, which is positive. Oh, it's gonna change things a bit. That should have been positive. My answer is going to be a bit different. Not a big deal. Let me see how I did this one. For point G. Point G. Okay. Okay, just continue. So then I have in here force FE, and then I have plus force GF minus force CF, and that is equal to I need my cosine in this case, minus cosine, again because I am moving from the tail of the arrow in this direction, negative makes a negative, so force CF cosine of 53, and that is equal to 0. Now, do I know some values in here? I know force FE. I don't know force GF. Okay, I don't know this here yet. I don't know what that is equal to just yet. So I'll move on. So then I'll do the sum of all forces along the y must equal 0. So then in this case, I have 1, 2, 3. So I have negative 20,000. Okay. Plus force FD. My plus actually force CF sine of 53, and that is equal to 0. In this case, I do know what force CD. Now, why did I have CD? CF. Force CF and force FD. So in this case, I actually know what force FD is equal to, and which is going to give me the value for CF, and then I can plug it in into this equation over here and to find the other value. So let's go ahead and do that. So I'm gonna have negative 20,000 Actually, let me move this to the other side of the question and then this to the other side of the question so that I can isolate this variable. So in doing so, I will end up with force CF is equal to positive 20,000. FD turned out to be, no, what am force FD? Do I know what force FD is? Force FD, where's it at? Oh, here it is, 25K. Oh, I have it as DF. Okay. And so then that is minus, once I move it to the other side of the equation, so minus 25,000. And okay, I skip a step, but I guess I'll add it in here. Notice how I only placed the 4CF sine 53. Because in my mind, I was already dividing by the sine of 53. So I have force CF sine of 53, which I know I have to divide by sine of 53 for both sides of the equation. So then force CF, once you put all of this on the calculator, it's going to give you force CF. That is going to give you, no, hold on, what's going on? Yeah, 4CF is going to give you 6 to 6, 0.7 newtons. Okay, and that is the value for that. So I wonder if we can now go and figure out what the other values are. So I know what, yep, we can actually do that. Now I know what FE is, I know what CF is, and I can find GF. Okay. So then I'm just gonna go ahead and isolate GF. So force GF. Once I do all of the math, I am going to end up with negative force FE minus force CF cosine of 53. Force GF is equal to well, FE, force FE is equal to 31. Oh no, not yet, not yet. Force FE, oh yeah, force FE is equal to negative 188. I move that to the other side, and then I move this to the other side. So that's negative times a negative 188.34. 188.34. Plus 4CF, we found that to be 6260. 6260.7 times cosine of 53. Negative times a negative is a positive. So then once you do all of this, you're going to end up with force GF is equal to force GF is equal to 22,606. So 22,606 0.62 newtons. Okay. So then we found more values now. So we just found, let me see. We found GF, right? We found GF, which is this one. We found CF, which is this one. Now we need to find the rest. So in order to find the rest, might be a good idea to do a moment about point E, so that we can find AY, and that will trickle down to the rest of the problems. This video has been already long. I guess I can continue. I am not sure how long this video has been already, but we can try and see if we can. It's not gonna let me put in the new picture. So I'll just do this. I'm gonna do the sum. I'm gonna have going positive the sum of all forces about point. I did in this case I did the moments about what, point A. I'm gonna do about point E, and they must equal 0. So if I do that, based off of the notes that I currently had in here, just to make things a bit easier, quick sketch. It's gonna look like that. I have 40K, I have 20K EY, and I have AY. Okay, and measurements, you guys already know, is 1.5, this is 3, and that's 1.5. So then the moment of a point E, I'm gonna have negative. Well, actually, let me start at the end. So AY times 6, right? So that's gonna be positive. So 6XY minus 40K times 4.5 minus 20K times 1.5. Should have done this. And that is going to go to 0. 6AY, once you do all of the math, you're gonna end up with 2, 1, 3 zeros. So AY will give you 35 kilonewtons. Okay. And so then 35 kilonewtons. So we just found something else. So we go back to this case over here, found AY, and now we can actually AY is here, so we can find force AB. So AY turned out to be 35,000 newtons. So then we just move this to the other side of the equation. So then we have with force AB, sine of 53 is equal to AY divided by sine of 53, both sides of the equation. Just trying to do this as quick as possible. So force AB is equal to 35K divided by the sine of 53, which is going to tell us that force AB is equal to um, 4, 3, 8, 24. No, yeah, 4, 8, 4, 3, 8, 24 newtons. So there you go. We just found one more. Let's go back over here and cross something else. So we just found that. Now we just need to find force BC, GC, and AG. Can I possibly find something else from here? I found AB. Do I know what AG is? No, not yet. Okay, so what that means is that I need to what else do I need to do? Well, now I need to do a free body diagram at point G, I guess, and see if we can do anything about that. BC. Yeah, we might need to do free body diagram at point B as well. You know what? Let's do about point B. And if we do that, that's gonna give us force BG, and that's gonna give us force BC. And the only thing that we're gonna be left with is just gonna be point AG and CG, and I might just leave you guys with that again because I don't want to make this whole problem longer than what it is already. So yeah, so okay, so let's do point free body diagram at point B. Point B, I have this force in this direction, and that is force AB. I have this force going in that direction, and that is force BC. Then I have this force, and that is force BG. Okay, have I done the free body diagram or the vector components for AB? Yeah, here it is. And I have the vector components already, which is this one and that one, which are the ones that I'm going to use. So now do the sum of all forces in the x equals 0. In this case, I have force BG, or no, in the x I have negative force BC. That should have been the opposite way actually. That's fine. So then I have force BC and plus force AB cosine of 53 is equal to 0. I know force AB. Yeah, I know force AB. So I can just plug it in, and that's going to give me force BC. So force BC is equal to negative force AB cosine of 53. Once I do that, force BC is equal to AB, which in this case, force AB turned out to be what? Force AB, where's force AB? 43, 824. 43, 824 cosine of 53. So once you put this on the calculator, your force BC is going to be negative 26,374 newtons. Okay. And so then now I can do the sum of all forces along the y. Sum of all forces that move along the y. I have positive force BG Let me do this right. So I have force BG, and then I also have positive uh, force of is that right? Yeah, because that one's moving up, so it's gonna be positive uh, force AB sine of 53 is equal to 0. And so then again, I know what force AB is equal to, so force BG is equal to negative 43 824 cosine of 53. Once you put this on the calculator, you're gonna find that force BG is equal to 35 negative 35,000 newtons. Okay. And so now we found force BC and BG. So force BC and force BG. So now we just need to find force GC. GC and actually we can find AX and AG. I don't know if I should do that. Again, this video is pretty long already as it is. Maybe I can just give you guys what those values are. You know what? Okay, let's just do it. Let's do it super quick. I'm gonna go to the other section. So at G, so point G, I have a whole bunch of forces, right? So one is force BG. I also have this force right here, which is force GC. I have this force, which is 40,000. I have force AG, and I have this force, which is force GF. Okay. Okay, so now I have to do a vector component breakdown for force GC, and I am going to have this as 53 degrees just because of how everything has worked out. So sine of 53 is equal to y times force GC, and force GC cosine of 53 is equal to the x component. I can now do the sum of all forces along the x and the sum of all forces along the y. So along the x, I have negative force AG plus force GF. And then this other one, force GC should be positive in this case. So plus force GC cosine of 53 is equal to 0. From here, we can actually find force AG, so I'm going to move that to the other side of the equation. If I do that, I end up with force GF, which I already know that it's equal to 22, I think so, GF, 22,606.6, and plus force GC. What was force GC equal to? Force GC um where is it at? GC force FE FETE GF. Do I have GF? Is that what I'm looking for? No, GC and GF. Oh, well, GC, I don't know what that is equal to just yet. I guess I have to wait until I do the sum of forces on the Y. So let's go ahead and do that. Sum of all forces on the Y must equal 0. So I have negative 40,000 plus force BG plus force GC sine of 53 is equal to 0. Now, so I know what force BG is equal to. Yes, I already know. Force BG in this case turned out to be 35K. So then that is going to be, I'm gonna move everything. I'm gonna move this and this to the other side of the equation, and then I'm gonna divide that by sine of 53 all in one step. So that way I end up with force GC equals to 40,000 minus 35,000 all over sine of 53. So what I end up with is that force GC is equal to 6260.67 newtons. Okay. And now I can plug this in here. So that is going to be 6260.67 times the cosine of 53. Once you put all of this into the calculator, your force AG is gonna turn out to be, if I'm not mistaken, 26,374 newtons. And I think I'm gonna leave it at that. I'll leave it at that. You guys have enough information now to be able to find the rest. So I found AG and GC. I found AG and GC. And so now the last thing is just to find the value of AX. And which you guys can just go ahead and go to here. We know what AB, AG is equal to. You know what? Since I'm here, might as well. Okay, so the last point, last point, you plug in all the values, and so then your AX is just gonna turn out to be a very small number, 0.4 newtons. And for some reason they just neglect this since it's very small, and they let it go to be equal to 0 newtons. It is what it is. I would, in a test or something like that, I will still would want to see what value you end up getting. So for me, I would want to see that right there. And that is it. That's the end of this long video. I hope this helped. Make sure you guys study.